Welcome, everybody. Thank you for joining. Good morning, good afternoon, good evening, wherever you're watching this from. And welcome to today's stream. Thank you, Nathan, for taking the time, and obviously welcome to you as well. Thank you for coming today.
Thank you so much, Alexander. It's great to be here.
You are a little bit quiet, and I have a sore throat. Could you maybe check if you have either the right microphone selected or put it a little bit closer to you?
I will try that. Is that better?
Slightly, but not much.
Well, perhaps I will switch to a headset. Just a moment.
But I can increase your volume a little bit. But yeah, if you have a headset, maybe that could be helpful.
I'll be right back.
All right. While Nathan looks for his headset, I'll take the opportunity to give a little intro. And before I dive into the actual topic, though, I would like to mention that Graph Connect is coming up. Graph Connect is our it used to be yearly, but now it's obviously for reasons everybody knows has been a while. But we'll be back this year in Austin, Texas. So and actually in less than a month now, it's coming up quickly. We will be in Austin, Texas, looking forward to meeting you all there. Hopefully, some of you can make it. Check it out. The agenda is building. I'll post a link in chat as well. It's between 6th and 8th of June. There's a video you can watch, and the high level agenda is already live. So you'll see more like an overview here. Training session, welcome reception is on Monday. On Tuesday and Wednesday is the actual conference with full length sessions and expo hall and networking events. So I think it's going to be fun. Some of the sessions already are here. If you scroll some further down, you can look for sessions and for presenters. And I think it's going to be great. And I'm looking very much forward to meeting many people. And I'm hoping that some of you will be there as well. Nathan, will you be there?
I will be. Yes, I'll be presenting a couple of sessions and teaching one of the training classes. It's going to be a great conference.
Cool. So that's another reason for you all to come to meet Nathan for sure. And that audio quality is much better now. Thank you for
good. I'm glad.
for that headset. But today, as promised, we're going to look into Neo4j graph data science. So I'll share the link in chat as well, and this page which you'll find on our website. So the Neo4j graph data science library it has been around now for quite a while. It started out as a Neo4j labs project with some rudimentary features and has then built up now to the latest edition 2.0, which is something we're going to dive in today. I just an overview. If you don't know what Neo4j graph data science is, it's our graph analytics kind of library on top of Neo4j to run machine learning, graph embeddings, graph algorithms on top of your data in Neo4j, and it's I don't know the exact count, to be honest. Now it used to be 60. I think it's probably more than here it is 65 graph algorithms currently in that library. So you can do everything from shortest path to very elaborate things like a community detection or a path finding or similarity or something like that. So it's very it's very powerful. It has lots of features, and I'm looking forward to diving into that a little bit more today, especially what's new with the 2.0 version, but also what's in store in general if you're using the graph data science library. Let me share that link in chat with you. And before we dive in, one more thing I'd like to add, and then obviously Nathan, handing it over to you, is we'd like to obviously make this interactive and lively. So if you have any question, anything is interesting to you in particular when you're watching this live, let us know in chat, type it in. We can pause and dive in some extent into this. So if you don't ask questions, we do we do the things we have sort of planned. But if you want to go into some sort of a direction where we haven't necessarily thought about, and then you have some questions, and we for sure have time and the space to explore that a bit. That the stage is open, so everybody can post the questions. With that, maybe Nathan, you want to say a few words who you are, what you're doing, and then we go into the topic.
Yes, it's great to be on the stream today and talking to the community. I am a senior data scientist with Neo4j Professional Services, and so I get the wonderful opportunity to work with various customers at Neo4j and see how they are implementing graph data science to get even more insights out of their graph data. And I'm based in the United States. I live in Kansas City, Missouri. I've been working for Neo4j for over 6 months now, and it's been just great. You know, a lot of my favorite projects before I came to work for Neo4j had to do with graph databases, and now that all my projects do, I'm just really enjoying this opportunity to work with our customers and learn more about graph. And I'm,
Cool.
yeah,
Yeah.
and I'm so
But
excited.
you joined the maybe for some people who remember you from earlier, because you've been a frequent guest in this stream, thankfully, and before you also been an active member of the community. So if you remember Nathan from before half a year ago, then you might remember him from the Kansas City user group and from other community activities where he was involved and still is involved a lot. So that's another point, I guess, of interest.
Absolutely, yes. Yeah, and this topic today is so much fun to talk about. You know, I've used the Graph Data Science Library for several years in its various iterations, and I think 2.0 has so many wonderful, neat features. It's just going to make it even more fun to work with. I find myself noticeably more productive working with 2.0 than I was even with 1.8 in the previous versions, because the team has done such a good job of delivering features that make my life as a data scientist easier.
Mm-hmm. That's cool. Yeah, I think that's the. I mean, obviously, new features and better performance and all of that is great and a very important part of every new release. But I think also accessibility and user experience and user journey, right, is at least I think for all our products, be it the graph database or the graph data science library or other tools like Data Importer or Neo4j Bloom, it's always very important that this is as much as accessible as possible for users, as fun as possible, and as easy to use as possible. So it's come a long way. So that's a big step for all the versions, I think, to make
Yeah, I
it
agree.
easier.
So one of my favorite things about GDS 2.0 is this brand new Python client that was released as part of it. And I made a little demo notebook to celebrate. So do you want to walk through that together?
Yeah, let's do that. Maybe before we do that, should we say a few words? Where can people get the graph data science 2.0 version? Where can they use it, and how is it? Maybe how how to get started before and then we show the demo.
Yeah, that's a great idea. You know, there's several ways that you can get started with the Graph Data Science Library. One of the simplest ways is one that we'll walk through in the demo, which is just to
Mhm.
start a Neo4j sandbox. It's free. You just have to sign up, and then you can use a sandbox that has the Graph Data Science Library already installed and do some explorations that way. It also is a one-click install if you download Neo4j Desktop and you're doing some local experimentation on your desktop. Then you can also add Graph Data Science to that with just one click in Desktop and be experimenting there locally. And then one of the really exciting new announcements is AuraDS that just came out in conjunction with Neo4j Graph Data Science 2.0, where now within Google Cloud, there's a hosted environment. You don't have to install anything. You just have to sign up and give your credit card, and you're going to be up and going very quickly with a hosted managed environment where all you have to do is it's just the fun part, right? You don't have to worry about the installation and package management and backups, and all those things are all taken care of for you. The scaling, you can scale it up and down as you need to. So AuraDS is super exciting. That's been something that we've been looking forward to for a while. And it's so nice to be able to have customers in there and working in that environment as well. And then it's also certainly available on our downloads center that you can download. There's a community edition of GDS, and then there's the enterprise edition of GDS. And so you can download both of them. And really the only difference is if you're using enterprise edition, then you have a license key that you get from your sales team that would turn on the enterprise features, but it's really the same download that you put in your plugins directory on your if you're having a local installation of Neo4j instead of the Aura version of it.
Mm-hmm. Cool. Perfect. I posted the link to the download page in chat. Everything else, I think you said. I think it should be accessible and very easy on our to find via the Graph Data Science homepage I posted earlier. So yeah, I think we can dive in maybe while you get the Colab ready. Amy asks, can we use Neo4j from Azure? Yes, you can. There is on Azure in the Microsoft Marketplace or in the Azure Marketplace, there is a enterprise. Yes, the enterprise edition basically for you to choose. You can deploy on Azure with your own license key or buy it from there. Or yeah. So yes, answer is yes. You can. I can. Let me get the link. I'll answer to you directly in chat with the link to the docs about Neo4j on Azure.
Fantastic. Well, so what I have up here on my screen. Oh, just a moment. I'm having a little difficulty with sharing the screen. Let's see.
Sometimes it needs some additional approval of rights.
Yeah. We'll get that taken care of here real quickly. Apologize for that delay.
No worries. Let's see another question here. Marcos, is it possible? I would like to see some sample in scientific collaborations, knowledge graph using graph machine learning with GDS. Yes, I guess we'll go about some examples and show how it's done and how you could start your journey. If you're interested in scientific collaboration or knowledge graphs in particular, there are plenty out there. One that comes to mind directly is more on the in the world of pharma or life sciences is a project called Health Echo. I can share the link in chat. That's like it used to be all about COVID graph. This project now evolved a little bit outside of that. It's going to be more of a knowledge graph on all things medicine or life science related. So that's an open community you can dive into and exchange with these people there. Beyond that, I think there's probably plenty others that I just can't remember right now. But go to community.neo4j.com, which is our community forum, and then there's a very very active community there. And now I see your screen, Nathan.
Oh, wonderful.
Here we go.
Okay, very
Yes.
good.
Here it
So
is.
this screen right now is the Neo4j Sandbox. And so I just wanted to show you, if you're brand new to Neo4j Graph Data Science and want to get involved with the Sandbox, you just sign in and then you pick a new project. And the project that we're going to use for our demo is this Graph Data Science project. You can see we've got several different data sets that are fun to work with that have pre-built data, but we're going to use the one for Graph Data Science. So I just highlight that. And then I select Create. And then it takes just a moment for it to be set up. You'll see here that it tells me it expires in about 3 days. That can be extended, but this is a finite sandbox. It won't stay around forever. And so now when I expand this, I can see that I have the connection details. And that's exactly what I'm going to need to work with in my Python environment. I'm going to need the username, which is easy to remember. It's Neo4j. The password is here. And then there's a bolt URL. Those are the 3 ingredients that I need to be able to connect to a Neo4j instance using the new Python client. So I'm going to stop sharing that tab now and share my Colab notebook with you. So I'm using Google Colab because it's a familiar environment for a lot of people, but any Python environment would be fine. If I wanted to use a Jupyter notebook locally, or Amazon SageMaker, or with the Databricks Azure environment, wherever you can use Jupyter or Python, these tools are going to work. And then in the first cell of my notebook, I have already installed the Graph Data Science library. And so if you don't have this Python client installed yet, this is the command that it would take: pip install Graph Data Science. And then I can just import the library and it's ready to use. Oops, I restarted my Colab environment. I need to actually do the install so we can demonstrate that part as well. So that takes just a moment. And now this should work better. There we go. Good. So we've got that installed. And for you, I've already created the sandbox and launched the sandbox. And so now I'm just going to copy in the bolt URL, replace the old bolt when I was working on this earlier. And it's got the same username. And then I'm going to paste in the new password for my sandbox. There we go. So now I have a connection to Graph Data Science. And this new library, there's documentation on all the different things that I can do with this GDS object. But one of the simple things that I can do is execute this run Cypher command. So any Cypher that I could be running in Neo4j browser, I can run it here in my Python environment. It's going to execute Cypher command, and then it's going to return the results as a pandas data frame. And so if I run this, there we go. So it returned a list of all the labels that are in my pre-populated data set in that sandbox, and also the count of each node that has that particular label. So I could do that before when I was working with earlier versions of GDS and Neo4j. The Python driver for Neo4j does a lot of this as well. But what the GDS driver does is takes a lot of the most common things that I would do about running Cypher and just makes it all into this one line. I don't have to worry about transactions and sessions and various things that when I'm just working interactively in a notebook, I'm not really worried about that level of detail of transaction management usually. I just want to run the Cypher. And I also, when I get the results, I want to turn them into a data frame. So this kind of all of my most common use cases for the Python driver when I'm executing Python, or when I'm executing Cypher, now are handled for me by this simple one-line gds.run Cypher. So that by itself is a nice step forward for me when I'm working in a Python environment with GDS.
Yeah, that's cool.
Yeah.
Quick question from chat for the remainder of the session. Are we touching graph embeddings today, or is this maybe for another session?
I don't plan in this demo. I didn't get into graph embeddings, but maybe we could demo a little bit towards the end. There's not a lot of new graph embedding algorithms that have been released as part of this, but the way they interact with them in Python is new. So I think I can probably demo that towards the end of the session here. That's a good idea. So one of the things that is new with the 2.0 that's a breaking change if you have code that you've written with earlier versions of GDS is that they changed the name of the function for how we create in-memory graph projections. It used to be called gds.graph.create, gds.graph.create, and they've changed that name to gds.graph.project. And I like the name project better than create because we're not like creating new databases or anything. We're just projecting the nodes and relationships from an existing database into this in-memory workspace. And so I support that change, but that's something to be aware of. If you've got code from before, that you'll need to update it to change that name to gdf.graph.project. But here in the Python client, when I run this, this is going to be the name of my in-memory graph projection. This is the list of nodes that I want, and these are the relationships between the nodes that I want to include in that projection. And then it's going to return to me both an object that represents the graph, as well as a table that represents the results of the projection. So I'm going to go ahead and run this. It'll take just a moment, and when it's through, we'll see the results. There we go. There's the results. So it's got the node projection, the relationship. I can see that I projected 3,503 nodes and 46,389 relationships. And so now that I have this groutes object, I can do all kinds of interesting things with it. It also has some properties that I can just call by itself. Like if I want to know the name of the node, I mean the name of the graph, it's called AuraDS. If I want to see the node count, I can get the number of nodes. So I can use some properties off of that new graph object just by itself, but then it's also going to be something that I'll pass in to various other algorithms to do the actual interesting work. So now that I have a graph object, I can start calling all of my favorite graph data science algorithms, and I'm doing it right here in Python. So here I want to call the weakly connected components algorithm. Weakly connected components just tells me how many groups of nodes do I have within the graph where each node within the group is reachable along some path to all the other nodes that are part of that same group. And so the syntax here is I say gds.wcc, which is weakly connected components, .stats. So each of our different algorithms can be called in different modes, whether it's write mode or mutate mode or estimate mode. So here I'm calling this algorithm in stats mode, and then I just pass in the graph object, and then it returns to me a data frame. So let's run that and see how it works. There we go. So then when I call it, it's got several different properties that came back from that object. And here's the distribution of components. So I've got one giant component that has 3,292 nodes in it. And then it looks like I've got a bunch of much smaller components, many of them that have just a single node inside them. So that's interesting insight that I can get from running that algorithm. And then as far as the syntax, if I was going to run this same exact command in Neo4j browser, I would just, in Cypher, I would say call, and then it would look just like this, except for instead of passing the Python object, I would pass the name of the graph. So when you're translating code switching back and forth between Cypher or your Neo4j browser and the Python client, it's very, very similar. The same exact function names, everything that you would put after the word call, you can just put attached to this GDS object in Python, and it works pretty much the same. So it's not hard if you're used to running it in Cypher to figure out how to use it with the Python client.
But it makes it easier for people who are very much more used to work out of Python and don't deal with Cypher that much or very little.
That's exactly right. And the other thing I love about it is usually as a data scientist, my workflow has several steps. It's not just one query or one algorithm call. Is usually this chain of things that are interesting to me. And so by putting them in a notebook like this, I can see exactly what steps I went through along the way, and I can reproduce it. Here I ran the same notebook earlier. I'm running it again now, and I can see if the results are the same. And so I really appreciate that ability, because as a data scientist, I work with Jupyter all the time, and so that workflow is very familiar to me. And now being able to use the graph data science tools in this workflow is really great. It really is a big productivity boost. So let's see, another thing that we can look at here is, now that I know that there's one giant component, I'm going to actually run this algorithm again, but this time I'm going to run it in mutate mode. So you can see what the syntax looks like. It's very similar, GDS WCC stats before. Now I'm running GDS WCC mutate, and that's going to update the in-memory graph. And then here's another example of that syntax. If I was running this in Cypher, I would pass the name of the graph, and then within curly braces, I would pass a map that had all of the different configurations that I wanted to use with that algorithm. Here, it's the same exact configuration parameters, but I don't put the curly braces, and these are just keyword arguments that I would use in any other Python function. So when you look in the documentation, you'll see when you run gds.wcc mutate, one of the configuration parameters is mutate property. And so I can pick out any of those configuration parameters that I want, add them into the function signature here, and just pass it as a keyword equals, and then the value. So we'll run that. And so that's added that WCC ID to the graph. And then here's another way that we can run these algorithms. I'm going to run it in stream, or actually I'm going to call this graph stream node property to get that property back. I created this WCC ID property. Here I'm going to get it back. And this is where it returns a pandas data frame that has the ID of the node and then the value of the property. So if I look at the first 5 rows, you can see that these first 5 rows all have that property value of 0 for the WCC ID. And then here, now I'm just manipulating this data frame like any other pandas data frame. This isn't Neo4j code. This is just take that data frame, give me the value counts, sort the values in descending order. So I can see that the weakly connected component with ID 0 is the one that has 3,292 nodes in it. And then all these other components have just a single node. So those are just like little islands. So since this is about airports and the routes connecting them, I'm going to assume that these little airports are maybe general aviation airports where they don't have commercial routes that go between them. And so that's why the airports are isolated like that. But then these other ones in component 0 are the ones that have commercial routes that connect them, and they're all connected in one giant component. So then here's another new feature in GDS 2.0 that I am super excited about, and that's this ability to take my projected graph and break it down into different parts and project a subgraph. So here I'm going to call this function, and I'm going to make a brand new graph. It's called connected routes, and it's going to start from that old groutes graph that I had before, but then I'm going to filter it down, and I'm going to project only the nodes that have a WCC ID of 0. So when I'm doing this filtering here, N represents the nodes that are part of the groutes graph, and then if I had relationship filters, I could use R as the variable name to put filters on the relationships. I'm going to take all the relationships as long as the nodes in the relationships have this WCC ID of 0. So we'll run this and see the result. So now I've got a new graph. Its Python name is gconnected, and you can see that in Neo4j it's called connected.routes, and now it has 3,292 nodes in it. My old one had 3,503. So this is a subset of the graph, and you can see that the count there is matching the 3,292. So so that's a really nice feature. As I'm investigating, especially if I run this WCC first. This is a really common pattern. WCC is a great way to explore your graph and figure out the components that are in it. And this ability to take just the giant component to run certain algorithms on is really helpful. And to be able to just do it in one line like that is something I'm excited about. So now if I look at the list of graphs that I have in memory now, I have the full air routes graph and I have the connected air routes graph, so I can work with either one of them going forward.
Is because there was the question just came in from Lavanya, and it fits perfectly because just opened up this view, and she asked, is there a way to visualize the in-memory projected graph? Is there anything beyond the table view we have here? Could we potentially look at it?
Well, we'll see an example in a moment, but you do have the capability, not within Jupyter, without using some special. I mean, I wouldn't say that it's not possible in Jupyter, because Jupyter is very flexible. There's probably ways that I'm not even aware of. But when I want to visualize the graph and see the relationships in the nodes, that's where Neo4j Browser or Neo4j Bloom really shines. So that's where I would jump over to those tools to do the visualization of the relationships in the nodes. And I can create a Cypher database. So we have the capability to execute Cypher against this in-memory graph projection. And so that's probably beyond the scope of this demo.
Yeah.
But that's definitely a possibility to explore this projection by writing Cypher queries against it, getting the results back in Neo4j Browser, and looking at things visually in that way.
Cool. Yeah.
So now that we've got these graph projections, I'm going to call the PageRank algorithm, and I'm going to call it in stream mode. So that's going to give me a data frame back as a result. So I've got a standard pandas data frame, and so now I can use the data frame function of sample to return a sample of 25 rows back from that data frame. Again, I've got the node ID and I've got the score, and that's great. But something I've often wanted to do is say, well, I can look at these things and I can calculate the mean, I can calculate the median, and et cetera, and I can do that all with Cypher. But to be able to look at a statistic like that as a histogram is something I can't do in Neo4j Browser, and it's so easy to do it now here in Python. So I love being able to get the distribution. I can look at this and say, okay, so most of the nodes have a page rank that's between 0 and 1. There's a few, it must be some super connected node that's got a page rank up in the 12 range. And I can just look at that picture. It looks like it's got kind of a power law distribution, which is what we often see when we're dealing with node degree or centrality scores. So super useful to be able to just stream those property values back with syntax like that, and then take that data frame and visualize a histogram or a box plot or whatever, and understand those statistics a lot more easily because of the Python tooling that's available to me in this environment.
Yeah, it helps a lot. I mean, if it's and it's not the scope of this session today, but if you look at a table, look at a graph, and tell me what you see, and if you look at a table, it's going to be very much more difficult to find out what it's actually about. And the same applies here. And the table is fine, but here the histogram is much more visual, and I understand it within milliseconds. Basically, looking at it, and I see, okay, this is what it's about.
Yeah, exactly. I mean, looking up here, I can say, okay, well, there's one node that's got a 3. Most of them are zeros, but is 3 high? How high is 3? But look at this picture. Oh yeah, 3 is pretty central compared to the nodes in this graph. So yeah, love that capability. Oh, and now we're getting into another topic, which I think is really exciting. It's this new thing called Cypher aggregation. So it's another way of creating the graph projections, because the way we created the graph projection up here is super easy to use, where I just get all the airport nodes and all the HasRoute nodes, and that kind of native projection is very performant and it works really well in a lot of circumstances. But sometimes when I'm exploring a graph data science problem, I want to be able to slice and dice the data a little bit, exclude certain things or include certain things. And this Cypher aggregation really makes that easy for me to do. So this query I put in here just to remind us of how aggregation works in Cypher. So what's happening in this query is I'm going to match all the airport routes, and then I'm going to add another part of the match that requires that the airport 1, airport 2 are on the same continent. So this is going to give me all of the airports that are on the same continent. And then I'm going to return the name of the continent, um, the code for the airport, and then see here count star. Well, this is an aggregating function. And so in Cypher, anytime you have an aggregating function, the things that are not part of the aggregating function are the grouping elements, and then anything that's inside the function gets rolled up and aggregated, right? So in SQL, I've written group by a million times. In Cypher, I don't even have to write group by because it's smart enough to understand that things that are inside the aggregating function get aggregated, things that are outside of it are part of the grouping criteria, and so then it just returns them. And so when I do the run Cypher, it knows I want back a pandas data frame, so this will take just a second, and there we go. So here are the 15 airports that are connected to the most other airports on their same continent. So just a quick review of aggregation. Well, with GDS 2.0, we're taking this aggregation capability within Cypher and using it to create graph projections, which is pretty cool. So here is a very similar query where I've got the airports, and I'm going to require these airports are connected, and the airports are all on the North American continent. So airports connected to other airports within North America. So at this point in the query, I've got a list of airport 1, airport 2, and now here's the aggregating part, but instead of taking a sum or a count or whatever, I'm going to roll all of those A1 and A2 nodes up together. The A1 is the source, A2 is the target, and then the relationship between them gets projected as well. And this gets turned into a new in-memory graph called NA routes. And so when I run this, this is another way of creating an in-memory graph. And so it projected 931 nodes, 10,872 relationships. I didn't have to do like a distinct or anything. It just knew what to do. It took the results of this query and aggregated them together and made that graph for me. And so this graph exists in memory. Notice because I called gds.run Cypher, I didn't get the graph object itself as an output of this query, but I know the name of it. And so anytime you've got a query, anytime you've got a graph in memory, if you didn't create it within your session, you can just call gds.graph.get and pass the name of it. And now I have the Cypher version of it. So that's how you can retrieve, if you didn't create it within this session, but the graph is pre-existing, or if you did create it within this session, but you used this method where you ran a Cypher query to create it instead of calling gds.graph.project to create it, this is how you can get it back out of the in-memory graph catalog.
Mm-hmm.
And now that I've got it back, I can get the node count, whatever I want to do. Another thing that we can do, well, actually, we asked about graph embeddings. So let's see how we could run a graph embedding on this little graph before I drop it. So if I run GD, and now we're testing my live coding ability in my memory. But let's see. Stream. So let's see if this works. I hope that I'll have a new data frame that's going to call the FastRP algorithm in stream mode for the, oh wait, but you know what, for FastRP I need some properties. So it needs an embedding dimension, and we'll do 64 is kind of lightweight, but this is a small graph, so that's fine. And I'll do, yeah, I know I need at least that property
There's
for
a typo, Nathan. Embedding. You
What
typed
did I miss?
you're missing an embedding dimension.
Oh, thank you. There we go. That looks better. Okay, let's see if that's happy with me. Oh, it looks like it worked. Good. Let's look at the first few rows. Great, there they are. So we won't get into great detail about what we might do with those embeddings, but you can see any algorithm that's part of the library, easy to call it. You know, these graph embeddings are great because of you can use that as input for a downstream machine learning function. So if I wanted to train some machine learning algorithm that I've got already access to in my Python environment, whether it's from Keras or scikit-learn or PyTorch or whatever, you know, now I've got these embeddings, which could be features as inputs. And so I've got them right there in a data frame, and I can just take it right from here on into the next downstream task that I want to do with them in Python. So that's pretty nifty.
That's cool. That's also kind of answering question from Isaac. He says, for users of the insights coming out of the data science library, are there any action or decision layers that say, based on what we're seeing, this is what we should go do? So I guess this is like one of those examples right here.
Yeah, yeah. I mean, um, as far as what to do with these insights, that's as varied as the possible use cases.
Yeah.
But if I have a supervised machine learning problem where I've seen certain examples from the past, I can potentially apply those patterns I've observed in the past to new instances, and then figure out something to do with them as a result of that. Yeah. So another thing that you can do here within the Python library is just clean up your graphs, right? So my graph catalog in memory now has 3 graphs in it, and if I'm done with this one, this GNA, then just gds.graph.drop will get rid of it, and it tells me it was gone. So the thing to keep in mind with this Cypher aggregation is, just like I can have group by when I was doing my sum or my count, I can even have group by when I'm creating graphs. So let's look at this particular query together. So I'm going to match 2 airports that share a route connecting them, and I'm going to require that they're on the same continent, but I'm not going to require just North America. I'm going to say any continent. They just have to be part of the same continent. And then with that continent node as my grouping feature, I'm going to make graph projections, but now this time I'm going to make a separate graph projection for each continent. And I'm going to call the graph projection c.name-routes, and then still pass in the same airport 1, airport 2 as my source and target. And let's see what happens when this runs. Yeah, so now it's created 6 different in-memory graphs for me all at once. And then if I wanted to, see who's the most central in North America versus who's the most central in Europe or Asia, whatever, I've got the graphs there ready to do that. And that happened just with one little Cypher command. Here's and run the gds.graph.list, and now we can see that our in-memory graph catalog has quite a few more different in-memory graphs in it, and the different information that's available about each one. So powerful new things that we could never do before GDS 2.0 that I think we'll just continue to see new ideas and new ways to expand our creativity with this tool set that the product team keeps giving us. It's why my job is so fun. Yeah, it's going to be,
That's
it's
super
just,
cool.
yeah. And then here, one of the things as a lazy developer, sometimes I end up with multiple graph databases in memory at once, and I want to drop them all at once. Well, here, I've just got the list of my graphs, and this is going to give me the most recently created ones, those 6 that I just created just now. And then I can just iterate through that list and get that graph by name and then drop it. And so now I've dropped all 6 of those. And now when I run my list, I only see 2 left over. So, you just have that capability of managing your graph catalog easily with scripts in Python that you might not have had when we were having to do this before. So that's my...
So that's something you would do because you cannot keep. I mean, you depending on your on your server, but you cannot keep on your data science. You cannot keep infinite numbers of virtual graphs in memory at the same time. So you have to juggle around, and then you do some calculations, run some algorithms on it, and then you have some values. You like Isaac said, okay, then some decision is made or some result comes back. You write that back to your graph, and then you drop them the ones again, and then you spin up some new ones and continue doing so.
Yeah, that's exactly right, that iterative process. And when I do see something valuable, I would call that algorithm in write mode, or I would call the write node properties or write relationship properties to store it for later reference. But this gives me a great working sandbox where I can just work with these algorithms, stream the results back, and find the ones that are really interesting, and then save them for later.
Mm-hmm.
So that's kind of the end of the tour of the Python client, but that's not the end of features in GDS 2.0. There's so much good things. One of the things that I think is really nice, and this might be actually easier to understand if I just show the documentation, because I think they've done a very good job of creating documentation for all of our libraries. There's been a good improvement in reorganizing the similarity algorithms that come with GDS 2.0. And so now, before I found it a little bit confusing just as the library was maturing. There were several different ways to calculate similarity. And now it's really organized into 3 sections that I think make a lot of sense, but it might not be totally obvious the first time you're getting used to this. So the node similarity algorithms are based on finding similarity between 2 nodes that have common neighbors. So when I look at node similarity, this is going to be either using a Jacquard similarity definition or an overlap similarity definition, but they're both, I don't know if we've got a picture in here that shows this. Yeah. So in both cases, we're really looking at, when I look at this node and this node, how many of their neighbors are shared. And so since these 2 nodes have all 3 of their neighbors in common, these are going to have a very high node similarity score when we're using these algorithms. It has nothing to do with any properties. It's all about the graph topology and who has neighbors in common. So when you need to calculate that, you want to look at this node similarity algorithm. And these algorithms are great. I mean, they can do very large data sets. When you think about, it's really a big ask when I look at all of the orange nodes and ask them how many things that they have in common, because I need to compare guitar not just with synthesizer, but also guitar with bongos, guitar with trumpet. So you're looking at every possible combination of 2 nodes within your graph, and then you find out how similar they are. So it can be kind of an expensive operation, but I am impressed with how quickly Neo4j Graph Data Science is able to carry out that operation. And the result of this is going to be a new relationship that goes from guitar to synthesizer, and it will have a score that says what that similarity score is. And within the algorithm, you can configure it to only give me like the top 5 most similar nodes, or only write this new relationship if the similarity is above a certain threshold. So that way you don't end up with relationships between every single possible pair of nodes in the output. So that's
another great example of what this can do. And then you write your calculations give you some result. It means that you now have a new relationship between two nodes, and then you have established these connections. Then you can do something beyond with that. So you can then say, okay, if there is a connection between 2 nodes, and if there is they have a value, maybe let's say higher than X, And then that means they are very similar, and that would then result in some other, could be a recommendation, could be some other decision that is then derived from there, and that would then help you make your decisions, your actions, your path, what comes next, more concrete and more relevant for an outcome as a way of
Yeah,
driving.
I agree 100%. Yeah, often I will use this particular algorithm to generate those is similar relationships and then follow that up with community detection to figure out, oh, well, if these nodes are similar, then they kind of group together in this community and it starts to make a lot more sense about the structure of the graph. So yeah, it's good by itself, but it's also good in combination. And so much of what I want to know about a graph a lot of times is just who's alike, who's the
Mhm.
most similar person because of what you're saying that I can then recommend. If this person liked this other product, then who people similar to them will probably like it. Or, this course of action we know worked for this person, so let's recommend it to that person. Um, Similarity is such a powerful concept.
Yeah, absolutely.
And another way of thinking about similarity is the similarity functions. So whereas node similarity functions are dealing with the relationships and who has common neighbors, the similarity functions category down here is all about properties. So it has nothing to do, it totally ignores any relationships in the graph. This set of functions here is all about the properties within the graph. And there are a bunch of different ways of calculating this similarity, but usually what I'm going to have is a vector. Like in this example, I'll have two lists of numbers, and this is going to calculate the similarity between them based on one of these metrics. So this vector could come from anywhere. A lot of times this vector might come as the result of an embedding. Like we saw earlier, we ran that
Mhm.
FastRP embedding and we got a vector back. And then I could use one of these similarity functions to calculate the distance or the similarity between two different vectors. So when you see node similarity, think graph topology. When you see similarity functions, you need to be thinking about um, mathematical comparison between two sets of vectors. And those vectors often are going to be properties associated with nodes, but it's the number values that we're comparing, not the relationships within the graph for this one. And then similarity functions is node to node. So I've got, or vector to vector, I've got two vectors that I'm comparing. K-nearest neighbors extends this idea from the similarity function. It's got a lot of the same possible metrics that we're going to use to calculate the distance between. It's got Jacquard, overlap, it's got cosine, similarity, Pearson, Euclidean. So a lot of the same similarity functions that we had here are available to us in nearest neighbors. But the difference here is that I'm going to look at a node that's going to have a vector attached to it, and then I'm going to look at all of the other nodes in the graph that might have those vectors and find for this node who are its k closest neighbors based on whatever metric I have selected. So just like node similarity gave me back relationships that got added to the graph, k nearest neighbors is also going to give me back relationships that are added to the graph. It's just that the difference is that node similarity, again, is based on common neighbors. K nearest neighbors is based on these vector calculations based on the property vectors between the two graphs, or between the two nodes.
Mhm.
So that's, like I say, that's been reorganized since the previous iteration of GDS, but I think this organization makes much more sense to me than how we had it in the past. Just an important change to note. And then the other change, or the other big new feature as far as tools that we can use within GDS is um, has to do with the machine learning pipelines. And this could be a whole other topic for a whole other streaming session. But we have the capability of
Maybe
doing
it will
machine
be.
learning. Yeah, I think that would be fun.
Yeah.
Um, but we have the capability of doing machine learning right within Neo4j. So it's not like I have to export out to Python and do my machine learning over there and then push the results back to Neo4j. Right within the database, I can do machine learning in Neo4j, which has the potential to offer a lot of efficiency, right? Because moving the data around, taking it out of the Neo4j memory, putting it into the Python memory, doing the calculation there, and then putting it back to Neo4j is fine from a lot of cases. But if you've got bigger data sets or just for the purpose of efficiency, um, doing it all in Neo4j is a pretty exciting opportunity. And the other thing is that I love about the pipelines is that there is some nuance when you're trying to work with graph data in a machine learning context. And the pipelines help you think through the nuance of how do I do a train test split without data leakage when everything in the graph is already connected. And so taking away the test set is going to impact the train set. So how do I break this down? And some of the the habits that I have as building machine learning models on tabular data, they translate, but they don't translate without a little forethought into doing machine learning models on a graph. And the pipelines are already set up to help you kind of think through that and have a good best practices pattern as you're building those machine learning models. And so I think it's a great way to get your feet wet if you're trying to do link prediction or if you're trying to do node classification based on graph data. I think it's worthwhile to look at how they've set up those machine learning pipelines within Neo4j, even if you later decide, you know what, I want to use some other tool to actually do my machine learning. I think you'll learn a lot just from walking through it in the Neo4j way through those pipelines. And one of the exciting things that's new with GDS 2.0 is in the past, the only machine learning prediction algorithm you had available was logistic regression for supervised classification problems. And now with 2.0, you have the opportunity to use random forest. And I think that's going to be really helpful to us because a lot of times these graphy features may or may not have a linear relationship to the target variable. Random forest, I think, is going to help us pick up some of those interactions and things that might have required a little extra feature engineering if you're going to do it just with logistic regression. So nice to see additional tools in the Neo4j machine learning toolkit becoming available with this release.
Do you have any tips to where people could read on about this? Is there a guide? Is there a blog post
Yeah,
or something else which would help?
Yeah, I think a good place to start is just in the documentation here. When I look under
Mhm.
machine learning, it's got the node classification pipelines and the link prediction pipelines that you can read about here. The pipeline catalog is new with 2.0, where I can keep track of the pipelines more easily because they're listed just like I have a graph catalog that lists all my graph projections. Now I have a pipeline catalog that lists all my pipelines. So this is a good place to start. I know that there have been some good white papers and tutorials written walking through how to do this. And I would also, for sure, if you haven't heard about Thomas Britannic's new book that is available in the early chapters from the Manning publishing site, I know that he's going to cover this in detail in his book if he hasn't got a chapter out about it already for early release. So that will be another great resource forthcoming on how to use these tools.
Yeah, Thomas is a great source for all kinds of things in the written world of graph data science. I'll put the link in the description to his Medium blog. So
Yes.
that's a great way to read up on it. I think, yeah, like you said, the book is not out yet. If there is a preview available, then I'll also add the link. I don't have it handy right now. If not, then it'll come. I know it's coming. It's at least planned for later this year. So that's something to look
Yeah,
forward to. Yeah.
I think some of the chapters are available now, and
Okay.
with that Manning's program, they'll let you get the new chapters as he publishes them. So,
Okay. Yeah, I'll put the link in the description after the video.
yeah. This is probably a good point to point out one of the important differences between the community edition of GDS and the enterprise edition as well. That the enterprise edition is really focused at helping you take these experiments that you're doing to production. And so when you are working in the community edition, you can train all these models that you want, but there's a limit to how many you can store in the catalog, and they're also only persisted in memory. So when you restart your server, you have to retrain your model. But when you move to Enterprise Edition, you pick up the ability to persist those models, and you can publish them and share them with other users. So a lot of the features that I would want when I'm moving from kind of a proof of concept to a production level deployment are going to come with Enterprise Edition. And this is an area where I especially notice the differences is in these trained models in the model catalog, that they've put a lot of effort towards the enterprise features. So that's just something to be aware of. Most of the other algorithms like PageRank and things like that, it might run a little slower, but you can still run it just fine, just like normal in the community edition. But when you're talking about the machine learning pieces in particular, there are some important differences between community edition and enterprise edition.
Mm-hmm. Cool.
So yeah, I think from the user standpoint, that really covers the highlights of things that are new and possible with GDS 2.0. But I also want to talk about from the administrator standpoint, there's some really, really important advances. And we talked a little bit about AuraDS already, but that's something that's only been out for a month now,
Yeah.
is that ability to just go to the AuraDS and sign up, put in your credit card, and you're going with Neo4j and the Graph Data Science Library already set up to go, and you can scale that environment up and down as you need to. You can pause it to save money when you're not using it. So many nice features there that allow, I think, especially a smaller team who doesn't, maybe you don't have a lot of DevOps people who are going to be able to support your experimental environment. It's a great way to get started with real data and real horsepower, and having the backups done for you, having the upgrades done all for you. So, Aura has been out for a while on the AuraDB side, where you could have
Yep.
a Neo4j database, but now you can have AuraDS as well. So excited about that new capability. And then another thing that I've run into on some of the customers that I worked with is they already have a cluster of Neo4j database instances set up. So they've got core instances that are there for high availability. In case one of the instances goes down, they can instantly fail over, and the other instances can pick up the slack. So they have that kind of environment already set up on premises, and they want to do data science as well. And it hasn't really been very easy to do that in the past, but now we have the capability for this hybrid type of scenario where I still have those three core database instances that are running, but then I can also add into that cluster a read replica that is just for data science. And that read replica can have a different configuration than the instances that are on the core. So it can have um, more heap memory. It can be a totally different size machine. It's still automatically going to get all the transactions that hit the core are going to be replicated over to the read replica. And then I can, do whatever gnarly algorithm that might take a long time and a lot of resources to run on that read replica without impacting the nodes that are on the core. And then when the results are done, if I want to write them back, it can push them back to the other instances. So even though it's a read replica, it actually can push results from that read replica back to the core. So for those enterprise customers, that's an enterprise feature. But if you're an enterprise customer that has that high availability type configuration on premises, that's another really exciting new feature that I run into with some of our customers. And then another enterprise feature that I think is really helpful is the ability to back up the graph, because sometimes these graph projections take a long time. Before the graph itself, the on-disk graph could always be backed up, but now I have the ability to also back up that in-memory projection, so that if my machine goes down for some reason or I need to take it offline, I can restore not only the on-disk graph, but that in-memory projection could come right back, and I can pick up right where I left off. So, we saw just in our little demo, I had 7 different in-memory graphs, and maybe one of those is really important, and I don't want to lose it, now we have the ability to back that up in Enterprise Edition 2.0. So just
cool.
a lot of features. Yeah, a lot of features that are making this, I think, more from an academic, can we do it, to now this is ready for production, ready for those kind of workloads, where it can really become central to companies' business process to take these insights and use them for the sky's the limit. It's really fun.
Yes, yeah, and then we saw a small glimpse of it today. A short tour around what's possible. Yeah, I hope you enjoyed this, and I hope you are willing to try it out yourselves. Right? It's the Sandbox is available for everybody to give it a test run if you wanna try it out there. Other means obviously AuraDS and desktop. So there's your options. I think that was great. Thank you very much, Nathan. That was super insightful, and I think this new new release brings so many new capabilities that it is like a huge step forward. So I'm looking forward to what you will all try out and do. So share it with us if you have anything worth sharing in our community or on Twitter or somewhere else, so that people can also explore. Happy to see that. Yeah, and with that, I think we are done for this session today. Thank you for watching. Thank you for your questions and for the interaction. I had a great time. Thank you, Nathan, definitely for preparing and for taking us through. So that was really great. And yeah, with that, I think we're at the end. Let us know what you think by obviously liking this video on YouTube or subscribing to the channel. So if you want to know more or see more what's coming up next. Speaking of which, Michael and I will be back on Monday on another AuraDB Discover AuraDB session. So where we will take a data set and go there. So if you wanna watch that or join that session, then click the buttons. And yeah, I think we are closing out. So thank you for watching again, and see you soon. Take care, everybody. Thank you, Nathan.
Welcome.
Bye.